These are the solutions to the Year 7 data prep test. First question. For 3 days, Mariam made a tally of the birds she saw in the park. These are the different types of birds: kookaburra, magpie, galah and rosella. What are the total number of magpies? So we need to look across this whole line. And we've got 1, 2, 3, 4 magpies in the park. Okay. Which column on the graph shows the total number of galahs? Let's look at how many galahs, this whole row. We want the total number. 1, 2, 3, 4, 5. We need the column that is 5 high. And the column that is 5 high is this one, because that's 4 and 6. So that is the number of galahs. The next question, question 1b. This graph shows the number of children in per family. So here, the way we read this graph, there are 4 families with 1 child. There are 8 families, because it says number of families. There are 8 families with 2 children. There are 6 families with 3 children, and there are 10 families with 4 children. Now, how many families had 1 child? Number of children, 1. How many families had 1 child? That's 4 families. How many families were surveyed? Number of families is along here. So we've got 4 families here. Here, in the next column, we've got 8 families. See, number of families for 2 children, it's 8 families. The next column, 6 families have 3 children. And the last column, 10 families have 4 children. So therefore, we add these up together. We've got 10, 20, 28 families. Now, the next question is not as easy as what you might think. How many children were involved in the survey? People were asked how many children in your family, and this is number of children down here. So 1 child, 4 families have 1 child. 8 families have 2 children. So how many children are all together here in this column? No, it's... So if I say to you, how many people here have 1 child in their family? 4 of you put your hand up. So that's 4 children. Does that make sense? Here I've got 4 children. How many people have 2 children in their family? And 8 people put their hand up. So how many kids is that? That's 8 times 2 is 16 kids. See, this is 1 times 4 is 4 kids. And I say, how many people have 3 children in the family? And 6 of you put your hand up. That's 3 times 6. We're talking about 18 children there. And how many people have 4 children in their family and 10 people put their hand up? That's 40 kids. So you can do your working on the graph like that. So how many children? We've got 4 plus what? 16 plus 18 plus 40. I've got 40, 60, 78 children. So 78 children. We're going to go to the next page. And for road service, this is the biggest sector, 43%. Which reason for road service has the smallest sector? It is the one with 2%, engine problems. And what causes, that's pretty easy, this one. What causes 5% of service calls? It's the ignition problems. Now, the next one, girls, you're going to need your ruler. Question D. Now, in a survey, 450 people were asked about their favourite takeaway food. So this whole graph represents 450 people. The results are displayed in the graph. And it says, all right, what is the most popular takeaway food? That one's an easy question. Which one? Hamburger. Right. But how many people chose pizza? Now, we know it's, you need to look, it's this many out of the total. So how are you going to measure it? You don't guess. You get a ruler out and you measure it exactly. And write it as a fraction. Do you think it's less than half? It's definitely less than half. It's probably about a third, but you don't write a third. You need to have an exact fraction. So the only way you're going to have an exact fraction is if you measure the length. So we're going to get a ruler now and measure the length. No, it's less than a half. So girls, if your answer is 600 people, pizza, that's ridiculous. We know it's less than a half. We're hoping it's going to be about 200, even less. All right? Because that would make sense. Pizza, when I look at it, I'm getting 4 about 4.7. 4.7 centimeters. So pizza is 4.7 out of a total length of about 13. All right, I'm getting about 13 or 12.9. We will make it straight and it's 13. So 4.7 out of 13. Girls, I know it's not a whole number, that 4.7, but it doesn't matter. 4.7 centimeters out of the 13 centimeters that the whole graph represents pizza. Okay, do you think, what's half of 13? Anyone? What's half of 6.5? So if I had 6.5 over 13, that would be exactly half the graph. But I've got 4.7 out of 13, that makes sense. That's less than half the graph. All right, now that's the fraction that shows. What if half the graph was pizza? Would you go a half of what to get how many pizzas? How much does the whole graph represent? 450. All right, so if there's 450 people, if pizza was a half, how many people liked pizza the most? 250. No, you'd do half of 450, wouldn't you? You'd do a half. Yes, that's right. So even though this fraction isn't nice, it's not a third and it's not a half, it doesn't matter. It's still a fraction. I do that fraction of 450. And that's how you do it on your calculator. So just think, you think to yourself, if it was half of the graph, I just do a half of 450. Of is times. If it was a third of the graph, I would do 1/3 of 450. It doesn't matter that it's 4.7 over 13. You do it the same way. This is a very accurate measurement that we've taken here. It's really accurate. It's exact, it's 4.7 out of 13. I know the fraction's got a decimal, but it doesn't matter. All right, so 4.7 over 13 times 450. What answer do we get? So we've got 162.6. Of course, there's no part people. You're going to round it to what? I'd probably go 163 people. It's closer to 163. So you can go 4.7 fraction button 13 times 450, or you can go 4.7 what? Plus, minus, times, or divide. 4.7 over 13. What other symbol on your calculator can you use? Divide. 4.7 divided by 13 times 450 is the other way you can do it. Got it? A fraction is a divide. Basically, Lucy went for a ride. She left home at 8 a.m. and got back at 6. This graph represents her journey. What's the total distance? So if she rides along here, see this point here, how many kilometres away from home is she? Distance from home, how many kilometres from home is she? 35. But then she rides from this bit back down. So what's the distance from there to there is 35. What about the distance from there back down? Is another 35. So she ends up riding 70 kilometres. She rides 35 up and 35 back. Got it? Look, we don't do a lot of travel graphs in Year 7. It's more next year, so I wouldn't worry about that one too much. All right? How much time did Lucy spend riding her bike during the day? Do you know what these bits are? The flat bits? Is she moving when it's flat? No. So how much time from there to there? No. Look at the time on the bottom. 8 a.m. to 10 a.m.
10 hours. 2 hours. 2 hours.
Well, no, she did have a break.
No, but she's not saying the whole day.
Here, she's not moving. Between 10 and 11, she's still 20 kilometres away from home. So she's moving from 8 till 11, from 8 till 10. Got it? That's 2 hours. And she's moving in all these bits. But when it's flat, she's not moving. So how far from there to there? What's this box? How far is a box? 1 hour and a half plus. Here she's standing still. How many hours here? She's moving here. How many hours? Each box is an hour, girls. We can do it another way. So 2 hours there. And how long is this time here? 1 hour. 6.5. The other way you could have done it is to go, well, from 8 a.m. to 6 p.m. is 10 hours. and I'm going to take out all her rest breaks. Or you could have done 10 hours minus 3.5 hours is 6.5 hours. Because if the whole lot's 10 hours, here's resting for an hour, that's resting for an hour, and this is resting for an hour and a half. So 10 minus 3.5 is 6.5, or you could just add up all the bits where she's moving. We do this in the frequency histogram shows the number of goals scored by a football team in a season. Do you remember how we did do histograms and there's no gaps between the columns? Okay. It says number of goals scored 3, number of games. So how many games did they score 3 goals in, girls? Girls, do you know how to read this?
3.
Good. How many games did they score 4 goals in? All right. It says, what is the total number of games played in the season? How do I do it? What do I do? 3 games here. Number of games. Number of games is this one. This is number of goals. 3 plus 7. See, girls, look at the label. Number of games is going up here. So I have to count all these. That's 3 games. That's 7 games. Don't add up the bottoms. 3 plus 7, no, plus 5, plus 1, plus 1, plus 4. So girls, if you're not sure, do I add these ones up? Do I add these ones up? How many games? Look for the axis that says number of games. That's 3 games. That's 7 games. You got it? All right, we got 8, and 6 is 14, and 5 is 19 games. Now, what is the total number of goals scored? 3 goals scored in how many games?
3.
So how many goals altogether in this column?
6.
How did you do that? 3 goals in 3 games. That's 3 goals, 3 goals, 3 goals.
9.
Thank you. 3 times 3 is 9. You get the idea? 4 goals scored in 7 games. What's the total number of goals scored? Number of goals scored, 4. That happened in 7 games. 4, 4, 4, 4, 4. Think, when you're playing soccer, yep, today we scored 4 goals. Another game we scored 4 goals. In a total of 7 games this season, we got 4 goals in each of those games. So that's 4 times 7, that's 28 goals in those games. 5 goals in how many games? 5, so what do? 5 times 5 is 25. 6 goals in 1 game. So how many goals? 6. 7 goals only in 1 game. That's 7 goals. 8 goals in 4 games. How many goals?
32.
Good. So I add them, all those totals up. 9 and the 28 and the 25 and the 6 and the 7. I mean, I can write 1 times 6, 1 times 7 and the 32. And I've got a total of, well, I've got 60, 85 and, no, it's not 82. 85 and 22. 107, someone work it out. Line graph, do you remember we joined the top centers? Girls, we did about 3 of these in class. I'm going to do them in another colour. Girls, the polygon joins the top centers of each column. Shh. Polygon's your line graph. Now, I haven't finished it. What am I supposed to do now?
Put it all the way down.
All the way down, and here? You must start and finish at the bottom on the horizontal axis. Girls, it's only worth a mark. If you don't put the lines down, you're going to get 0. Polygon is the line graph that joins the top middles or centers of each column, also starts and finishes on the horizontal axis. A survey was conducted where students were asked about 2 brands of smartphones that they preferred, and the results were that 48% preferred brand X and 52% preferred brand Y. Do you think those results are very different, or they're pretty close? They're pretty close. Now, look at these graphs. See this first graph? Doesn't brand Y look a lot bigger than brand X? Why? Because where does the axis start? At 46. So girls, this is misleading. It makes brand Y look 3 times as big, but it's not, because the column is 3 times higher. Do you see that? This is very misleading. It's not good. Why? Because it doesn't start at 0. Girls, what's wrong with these two start at 0? Is this okay? Is that how you do a graph? Yeah, that's too skinny. That's no good. The columns are a different width. Next one. What is wrong? And it doesn't start at 0, and 3D is not very good. This one. Now, do they really look that different? Okay. You would do that one. But it says which of the following should be used to ensure that the data is not misleading. But what happens if you are a company and brand Y, you own the brand Y company? Which graph do you think you would give if you were trying to get people to buy brand Y? Which graph would you give? You want to mislead the people. Which makes brand Y look the best? I don't think so. Oh, A or C. So if you wanted to make brand Y look so much better, you'd do A or C. But that's very misleading. It makes brand Y look a lot better than brand X, where it's not really. They're almost the same. So companies might decide to do it like A and C, but that's misleading, okay? The correct way of doing it is like graph D. Misleading graphs don't start at 0. Shh. So the misleading graphs do not start at 0. What else? So they do not start at 0. They have different widths of columns, have different column widths, or are 3-dimensional. You can just write 3D. Shh. So the misleading graphs do not start at 0. They might have different column, or they do have different column widths, or have 3 dimensions. They're the misleading ones. Okay, we're continuing. Question 3. Lara surveyed a group of students on the number of television sets owned at their homes, and the data is in this dot plot below. So the number of television sets in their homes. What does this column here of dots mean? One what? The number of television sets. So I say to you, how many TVs do you have? You say 1. How many people told me they've got 1 TV? 5. How many people have 2 TVs? 8. Etc. 3 TVs, 5. 4 TVs, 1. 5 TVs, 2 people. So when you interpret these things, just think, okay, they were asked how many TVs they had. 2 people have 5 TVs. 1 person has 4 TVs in their home. So how many students were surveyed? What do you count? 21 dots. They're the number of kids surveyed. Every time, if I asked you this question, I collected the data, I'll have that line with 1, 2, 3, 4, 5, and every time someone gives me an answer in the class, I'll be colouring in a dot. Someone says 3 TVs, I would have put the first dot. Someone else says 1 TV, I would have put a dot, etc. Till I build my graph up. So 21 students were surveyed. How many students had 3 TVs?
5.
And how many television sets? This is a hard one again. How many TVs are we talking about? In total, yeah. So 5 people have got 1 TV, that's 5 TVs. How many TVs are here? 2, 4, 6, 8, 10. 16, which is 8 times 2, yeah. 3, 6, 9, 12, 15 TVs. 4 TVs and 10 TVs. Let's add them up. 5 plus 16 plus 15 plus 4 plus 10. How many TVs? I've got 20, 30, 40, 50. 50 TVs. So girls, we've done this 3 times now. 3 times the same thing. We did it once with columns. We've done it with dots. I think we've done it twice with columns. Okay, so the same thing, 3 times. The ages of people residing, that means they're living in an aged care facility, is shown in the stem and leaf plot below. All right, do you remember how to read this? How old is this person? 59. Remember, it's an aged care facility. Don't tell me they're 5. All right, 59. How old's the eldest person? 83. Good. How old is the youngest? 59. How many residents were living in the aged care facility? What do I count? I don't count all this because that's 59. That 9 represents one person. That's 61, 63, 64. You don't count the stems. So let's just count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3. You count the box. You count the box. Girls, see this box? It's an unknown number. Can you tell me all the numbers it could be?
5, 6, 7.
Why can't it be another 4? Can it?
Yes.
It can be a 4, it can be a 5, it can be a 6, it can be a 7. So it could be a 4. There's no reason why we can't have repeats. Look, there's repeats everywhere. So it could be a 4, it could be a 5, 6, 7. Can it be an 8? Yes. So I'm just going to put down here that it could be a 4, a 5, a 6, a 7 or an 8. But the smallest is 4 and the largest is 8. You can have repeats. Catherine would like to find out the student's opinion about the present uniform at her school. She hands out the following questions to 10 of her friends. So she's trying to find out something about the whole school and she decides she's just going to ask her friends only in year 7. So is that a good sample that she's taking? No, it's very biased. It's what we call biased. So this is her question. Which of the following items of school uniform would you like to see changed? Blouse, skirt, shoes and pullover. Which of the following did Catherine use? Observation, census or sample?
Sample.
All right, she took a sample of the Bethlehem population. A census would be if she asked who? Everyone. A census is when you ask, when you survey. Is it a survey? Is when you ask everybody in the population. So a survey, a census is when you ask everyone in the population. Girls, you should know what a census is because who had a census just recently? Australia did, where everybody had to get online and fill in a questionnaire. The whole 20-something, or I don't know how many million households, I don't know how many households in Australia. Oh, well over 10 million, maybe 15 million houses, I don't know. 10 million? 9 million? So, census is when you ask everyone in the population. A sample is when you ask what? When you ask some people in the population.
A number of people.
Or a number of people in the population. Now, girls, the sample that Catherine took is not a very good sample. It's not representative of the whole school. It's just representative of her friends only. So the only way she could report her results is saying 10 of my friends think that, not the whole of Bethlehem thinks. Okay, next question. So census is when you ask everybody in the population, and a sample is when you ask some or part of the population. Some people, I wouldn't put part of the people, some people in the population. For each of the following investigations, classify the variable as categorical, numerical, discrete. There are 2 types of numerical. Discrete, 2 types of numbers. Discrete numbers or continuous numbers. So the first one, number of children in the family. How many kids in your family? Right. Is that a number or is it a... It's a number, so it's one of these 2. Discrete means that you can count it. Discrete can be counted. Discrete data can be counted. Did you just count how many kids in the family?
Yes.
What's categorical? Like colour of eyes or...
Questions asked without numbers.
All right, numerical continuous must be measured. Girls, you give me an example of something you measure.
A ruler.
Yeah, a length, a weight, a temperature. You use a ruler to measure. So discrete, you must count the data. If I say how many pets do you have and you start counting, that's discrete data. If I ask you a question and your answer is a number, it's numerical. Next question, most popular radio station in Sydney. Are you going to give me a number or a word? And that's a category.
Miss, what about like if you put the...
No, I don't care if it's 104.1, that is still still a name of the station, 104.1 Today FM.
Wait, what's the difference?
Right, a categorical might be smooth. It might be whatever else you might listen to. Okay? Nova 96.9 or whatever it is. It's called Nova. I don't know what the number is. Whatever. Next, the mass of a newborn baby. How does someone work that out?
Numerical continuous.
They measure it.
Measuring the baby.
It's measured and it will be a number. It's numerical, continuous, measured.